Hi, in this video, you will learn about the parabola function, how to identify the different forms of equation, the shape of the function, and the domain and range. Hi, today we're going to be doing functions and we're going to focus on parabola, right? I'm sure you're familiar with. So a parabola, it is a symmetrical curve. Sure you've seen it. It looks more like this. So if you throw it in your Cartesian plane, it can be upwards like that or downwards like that. So we're going to be focusing on parabola, right? So the most important thing that we need to know is the general formula of a parabola, which is y is equals to ax squared plus bx plus c, right? So this is the standard formula of a parabola. Now, what's most important is for us to note down what exactly are these terms here, right? So this one here, we know it as a gradient, or you can call it a slope. So it defines the slope of the parabola. And this one here, it defines the translation in the horizontal of the parabola. And then this one here, it is your y-intercept, right? So that is what is in this standard formula of a parabola. A parabola has other forms of equation. The first one we have is y is equals to a into x plus p all squared plus q. So this p can be plus or minus p, right? So this value here is the same as what I mentioned. It is the gradient or slope. And then this value here, it is the x value of the turning point. And this one here, it is the y value of the turning point, right? So what do I mean by that? So you have in your graph here, let's say looks more like this one. So now this graph here has a turning point at the origin. So the turning point, what we mean is, so the graph starts from a certain value of infinity and then it goes down up until it reaches this point here. So this is the turning point. So the curve will turn and then go up again, right? So this is the turning point of the function. So these values here, this one here and this one here, are the turning points of the function, right? So that is the first form of equation of a parabola. Now, the second form of equation of a parabola is y is equals to a into x minus r1 into x minus r2, which can also be written as y is equals to a into x minus x1 x minus x2. So it's the same thing. So different books write it differently. But what's important for you to understand here is that this a here is still the gradient or slope, and then this x1 here, which is the same as this one here, r1. So this x1 here, it is your x-intercept, where the graph touches the x-axis. And this x2 here, it is also your x-intercept. So if you have your function, if you draw, and then you have your graph like this. So for this graph here, it has 0 x-intercept, meaning that it only touches the origin. It does not touch the x-axis in other points, right? So this is the x-axis, this is the y-axis. So it doesn't touch other points, it only touches the origin. So if maybe you have a function that looks more like this one, so you know very well that you're going to have your x-intercept at this point and this point. So it's going to be these values here, right? So this is the second form of equation of a parabola. So now that we know all three forms of equation of a parabola, we need to identify the graph by using this gradient here, which is the same as this and this one here. So we need to identify the graph. So if the a value, which is the gradient, is greater than 0, so in this case, if it's greater than 0, it means that it's positive. So if this a value is positive, the graph will look like this. The graph is going to be concave up, right? So this means now that it is a smiley face, right? Just like when you write someone who's smiling, right? So maybe that's the way of remembering it. Now, so if the a value is less than 0 now, it means the gradient is negative, right? So if we were to draw the function, it's going to look more like this. So now, this means now that it is concave down. So in other terms, it has a sad face, right? So if you are sad, you're going to look more like this, which is a clear example. So now, this is how you define the shape of the graph depending on the value of a. If the value of a is greater than 0, then that means the gradient is positive, and you're going to have a function that is concave up. If your gradient or your value of a is less than 0, which is negative, you're going to have a function that is concave down. So now we're going to look at the domain and range of a parabola. So what is a domain? A domain, we basically talk of the x values of the function, right? And the range, we mostly talk of the y values of the function. So looking at a parabola that looks like this, right? So this parabola, we said that it has a smiley face, right? So the face is smiling. So now we are going to define the domain of this function. So we're going to read through the x values, interpret the x values of this function here. So if you take a look at the x values, so this is the x-axis, right? And this is the y-axis. So the x values are negative in this part of the graph and are positive in this part of the graph. But since the graph comes from a certain infinity value, which is negative, because in this part of the x-axis rather, we have negative values. So everything is negative here for the x-axis, right? So everything is negative in this part of the Cartesian plane for the x-axis. Everything is negative. So this means now that whatever values of x, where this graph comes from, because it comes from a negative infinity x values, right? So that's how we're going to define it. It comes from a negative infinity x values, and then it heads towards, because this part of the graph we're having all x values being positive, all x values being positive, because it goes in that direction, right? So, and it goes to positive infinity x values. Why are we using positive infinity x values and negative infinity? It's because the graph has an arrow here, so we don't know where it ends or where it begins. So this part, it's where it starts, and this part, it's where it ends. So, but like, we don't know at what value of x does the graph end. So it has an infinity ending. It is not defined. That's why we're going to use these signs here. So this basically is your domain, because it interprets the x values of your function. So now if we talk of the range, right? The range of the graph, we're talking of the y values, as I said, right? So now the y values in this part of the graph, they are negative, because this part is negative. The y values are negative all the way, even this side, they're negative. Negative y values, negative y values, right? But if you go to this part of the graph, this upper part, the y values are positive. The y values are positive. Every y value is positive, right? Every y value is just going to be positive. So now, how do you interpret that? The function, if you look at the function starting point is just at the origin, where we have an x value of 0 and a y value of 0. So it's just the origin, and it just heads upwards. So we don't have any negative values of y. So the beginning part, because the 0 where the graph starts is part of the graph, we're going to use a solid bracket. And then now we're going to interpret for values that are positive for the y, right? So if you take a look, as I said, every y value here is positive, every y value here is positive, every y value here is positive. So the graph starts from the origin and heads upwards. So it heads upwards, but we don't know where it ends. All we know is it heads towards positive infinity y values. That's why you're going to write here positive infinity y values. So you might be asking yourself, why did I use these type of brackets here, these type of brackets here, and these type of brackets here? Okay, the reason why I used these ones here is because we don't know where the graph ends or begin, right? We don't know where it ends and begins. So you need to use this smooth, I call it a smooth bracket, right? But if you know where the graph begins or end, you will use this solid one, either this or that. So that's how you know which bracket to use. So this one here is just going to be your range of the parabola. Thank you so much for watching. Bye for now. Thank you so much for watching. Make sure you subscribe and click that like button below.